Welcome to the second unit of switchgear and protection. The second unit is circuit interrupting devices. The devices used to interrupt the current in normal as well as abnormal condition in the power system is called as circuit interrupting devices. The common examples of circuit interrupting devices are fuses, isolators, circuit breaker, MCCB, MCB and switches. The circuit interrupting devices are used to disconnect the faulty part from the system, or it can also used to repair or maintenance of the power system. The first device used is isolator. Isolator is a switch which is connected on the both sides of the circuit breaker. As you can see here, the circuit breaker is connected in between isolator number 1 and isolator number 2. The isolator operates normally under the no load condition and it should carry the normal rated current continuously. There is a proper sequence while making the line off and making the line on. This sequence should be properly followed by the user. While making the line off, we have to first open the circuit breaker, then open isolator, and the earth switch used here is closed. While making the line off and while making the line on, we have to open the earth switch, and then isolator is closed and the circuit breaker is also closed. These two sequences are very important while breaking the contact. There are mainly three types of isolators. First one is as per the number of poles, second is as per the location of equipment, and third one is as per the operation of contact breaking. According to the first classification, they are further classified in single pole and three pole. According to second classification, as per the location, it is used for indoor and outdoor, and as per the operating contact breaking, they are classified in three types. First one is vertical break type isolator, second is horizontal break type isolator, and third one is pantograph type isolator. First of all, we are discussing about the vertical break isolator. In vertical break isolator, there are two support insulators are used. First one is this one and another support insulator is this. The fixed contact is fitted over the first insulator and moving contact is fitted over the another support insulator. The operating mechanism is placed at this place and there are motion between this fixed contact and this is moving contact. The number of insulation used here is decided according to the voltage rating. The handle is used to operate closing or opening of the contact. Whenever the signal is given to the moving contact moves in vertical direction. Therefore, it is called as vertical break isolator. The moving contact used here is moves in vertical direction. This type of isolators are used in the air circuit breaker and transformer bank, and these are suitable up to 25 kV. The second type of isolator is horizontal break isolator. This type of isolator has three supporting insulators. At the central insulator, the moving contact is hinged and remaining two insulator has fixed contact on it. The number of insulator used here is decided according to the voltage rating. The handle is used for opening and closing the contact. When the signal is given, moving contact moves in horizontal direction. Therefore, it is called as horizontal break isolator. This is used up to 66 kV and this is costly as compared to the vertical break isolator. The third type of isolator is vertical pantograph type isolator. This type of isolator has the concrete foundation. Above the concrete foundation, the support insulators are placed. These are the support insulators. This is the case of the closing of the contact, and this is the case of the opening of the contact. The basic structure remains same, as the support insulators are placed over the concrete foundation and the pantograph structure is placed over the insulators. There are mainly two contacts. This is move-in contact, and the bus bar contact is act as the fixed contact. The operating mechanism is connected to this type of rotary insulators. While opening the contact, the pantograph to terminal moves away from the center, and thus the downward movements takes place and the contacts are open. While closing the contact, the pantograph arms comes in contact with each other, and there is a upward movement of the pantograph. So there is a closing contact between them. This is how this type of isolator works. The pantograph type isolator is used for high voltages up to 400 kV and above. Second circuit interruptive device used is a fuse. Fuse is a simple protective device. It has a metallic piece which is connected to the circuit. This metallic piece melts when there is excessive current flow through it, and this will melt and break the electrical circuit. Thus, it is protected the device from the overload. There are mainly four types of fuses. First one is rewirable fuse. Second is totally enclosed cardioid fuse. Third one is HRC fuse, and fourth is expulsion fuse. Out of these four types of fuses, we are discussing HRC fuse. HRC means high rupturing capacity fuse. According to the construction point of view, as you can see here, there is a bridge of the element. This bridge is made up of tin. This outer part is made up of ceramic material, because the ceramic material is a fireproof material. The quartz powder is surrounded by the fuse element, and there is a end caps are provided to the system. These are two end caps, or we can say end contacts. While talking about the working, this fuse element is connected in series with the device, which is to be protected. Whenever the current flows through the device, the current will continue to flow from the fuse element also. Due to this, heat is produced in the fuse element. Under normal condition, that is, the current is below or equal to the rated value of current, then the heat produced will be less, and therefore the fuse element does not melt. Whenever fault occurs, the large amount of current flows through the device and the fuse. Due to this tin bridge melts. Due to this high amount of heat, there is a vaporization causes due to melting of fuse element. This vaporization of fuse element reacts with this quartz powder. The chemical reaction between them causes production of high insulating material in the fuse element. This will help to reduce the arc produced between the terminals. Only disadvantage of HRC fuse is they have to replace after each operation. The characteristics shown here are the characteristics of the fuse element. On the x-axis there is operating time, and on the y-axis there is fuse current. The curve has the shape of rectangular parabola. This indicates that the operating time and current has inverse relation, means as the current increases, the operating time decreases, and as the operating time decreases, there is operation of fuse element.